construction industry is one of the most hazardous in America, and the potential for fatal accidents exists at every work site. The number one killer of construction workers? Falls. From 1980 to 1989, almost 5,700 people died from work-related falls in America. Just about half of those were in construction, which is alarming since we employ only about 5% of the workforce. And the price of falls reaches beyond the pain and suffering of the victims and right into your pocket.
It has to be understood that there are 6 fatalities in the construction industry every day, and of those 6, 2 are from falls from elevation. So we have to manage this problem.
In an attempt to protect workers from falls, the Occupational Safety and Health Administration, OSHA, developed a new Subpart M fall protection rule. The rule requires you to provide fall protection and training for any worker who's exposed to a fall of 6 feet or more. Subpart M applies to all construction sites and activities except where more specific standards like scaffolds, ladders, and steel erection apply.
The contractors have to recognize that we have exposures to falls from elevations all over our job sites.
Our goal is to identify all fall hazards and then eliminate them before the work begins by pre-planning. For example, you can order permanent stairs with guardrails already attached. So, if you can't engineer the hazards out or eliminate them, you'll have to guard against them. Your first set of options include hole covers and 3 conventional fall protection systems. These systems are guardrails, safety nets, and personal fall arrest systems. OSHA considers any hole 2 inches or more in diameter at 6 feet or more above a lower level to be a fall hazard. And covers are one way to eliminate this hazard. But remember, workers can still be injured even if the hole is less than 6 feet above the lower level. So to eliminate the possibility of these injuries, cover all holes on the job. The covers have to support at least twice the weight of any employee who may be on the cover. This includes equipment or material the worker might be carrying. Covers in areas where scissor lifts or other construction vehicles are being operated are required to support at least twice the maximum axle load of the heaviest vehicle expected to cross over the cover. The covers have to be secured so they can't be easily removed by workers or displaced by wind or equipment. And finally, they must be color-coded or have the word hole or cover written on them. The first of the conventional systems, guardrails, are commonly used on open-sided floors, around floor and roof openings like skylights, on stairs, and on ramps or walkways. Whether made of wood, rope, or steel, all guardrails must meet specific design and structural requirements. Avoid using manila, plastic, or synthetic rope for railings because these materials are easily damaged and must be inspected far more often than wood, pipe, or steel. Under no circumstances can you use steel or plastic banding for railings. All railing systems must be smooth surface to prevent injury. Top rails must withstand a force of at least 200 pounds applied in a down and outward direction. They are required to be between 39 and 45 inches above the working surface. But remember, when you apply the 200-pound downward force, the top rails must never sag below 39 inches. Make sure mid-rails are installed halfway between the top rails and the working surface. If screens or mesh are used in place of the mid-rails, they must extend from the top rail to the working surface and along the entire rail system. And the mid-rails or any screening material used have to support a force of at least 150 pounds. All railing systems must have toe boards that are at least 3.5 inches high. The posts, wood, pipe, or angle iron, must be spaced no more than 8 feet on center. and the ends of all top and mid rails should not extend beyond the corner or end post. For wood guard rails, construction-grade lumber should be used. At a minimum, 2x4s for the posts and top rails, and 1x6s for the mid rails. Pipe railing systems are required to be at least 1.5 inch outside diameter, Schedule 40 pipe. If you use angle iron, it must be at least 2x2x3/8 inch stock. Another option is the wire rope guardrail system. The top and mid rails can't be any smaller than 1/4 inch cable and need to be flagged at least every 6 feet with a highly visible material, like caution or surveyor's tape. The wire rope must also be properly tightened so that when the 200-pound force is applied, it doesn't sag below 39 inches. A second conventional fall protection system is the safety net. Safety nets are most commonly used for steel erection, bridge construction, and large commercial projects. It's important to remember that you can't use just any net because the safety nets are specifically designed for fall protection. The mesh crossings must be secure. The net openings no more than 6 inches by 6 inches, and the border ropes or cables capable of supporting 5,000 pounds. When installed, the nets have to be placed as close as possible, but no more than 30 feet below the highest working surface. All safety nets must be installed leaving enough space underneath so if a worker falls, he won't hit anything below the net. Also, perimeter nets must reach out a minimum distance from the edge of the working area. The horizontal distance depends on the height of the fall. For example, if the fall is 5 feet or less, the net must extend 8 feet. Up to 10 feet, the net must extend 10 feet. And for any fall greater than 10 feet, the net must extend 13 feet. Once the net is in place as a system, you have to test it with a 400-pound bag of sand according to OSHA requirements. The nets have to be inspected weekly and after impacts for wear, damage, or deterioration. All defective nets must be repaired or replaced immediately. And workers should remove any material or debris that falls into the net as soon as possible, or no later than the end of the work shift. The third option for fall protection is the personal fall arrest system. These systems are used when no other systems are in place during steel erection, near open-sided floors, for work on elevated platforms, and during roofing work. The system is made up of a body belt or safety harness, a lanyard, and a tie-off or anchorage point. Let's begin with the body belt. Even if worn correctly, the belt can severely injure workers. This is why OSHA will not allow the use of body belts for fall arrest as of January 1st, 1998. After that, the belts can be used for positioning or fall restraint only. So, to better protect workers from falls, they should use full-body harnesses. The harness distributes forces throughout the body and decreases the chance of injury. It also holds the worker in an upright and more comfortable position when he falls. The second component of a personal fall arrest system is a lanyard. There are several types and styles of lanyards available. Lanyards can be made of rope, nylon strap, or steel. The rope lanyard stretches more than the nylon strap lanyard, but is more likely to be cut or damaged, so don't wrap it around a beam or sharp edge. Steel is very durable and should only be used with certain limitations in harsh work environments where other lanyards may be weakened. No matter what lanyard type or material is used, OSHA has set limits for the fall forces that workers can be exposed to. For example, if you're wearing a belt, the force must be no more than 900 pounds. With a harness, 1,800 pounds. Here's an example of what the stopping forces would be when wearing a belt with different lanyards. Say you have a 180-pound worker wearing a belt with a 6-foot rope lanyard. When he falls, the force on his waist will be over 2,000 pounds. With a nylon strap lanyard, the force would be 2,800 pounds. And with a steel lanyard, around 4,000 pounds. All of these forces are much more than the 2,000-pound force that is proven to be enough to seriously injure a person. One way to reduce these forces would be to use a shock-absorbing lanyard. If a worker falls, it can lengthen up to 3.5 feet. This allows for a soft, easy stop. Another variation of the shock-absorbing lanyard is the shock-absorbing pack. The pack can be attached in between the harness and the lanyard and works as a shock absorber if a worker falls. It's important to remember that a shock-absorbing pack must be used with steel lanyards. Because steel doesn't stretch, workers can be exposed to a tremendous force if they fall. Many brands of shock-absorbing packs and lanyards will display a warning strip if exposed to a fall. If this strip is seen, the pack or lanyard has to be destroyed. An option designed to increase worker comfort and not restrict movement are the retractable lanyards. There are primarily two types of retractables, nylon strap and steel cable. Both take up slack in the lanyard material so it stays out of the worker's way. The units can be easily moved or permanently mounted in place. And if a worker slips, the braking mechanism locks quickly to limit the fall to 2 feet or less. All lanyards and retractables are connected to harnesses by locking or non-locking snap hooks. Because of the threat of rollout, as of January 1st, 1998, non-locking snap hooks can no longer be used. And until then, they can only be attached to a D-ring when nothing else is attached to it. Reduce the possibility of rollout by using locking snap hooks. These hooks require pressure on both sides for them to open. The life and performance of personal fall arrest equipment can be maintained by visually inspecting it daily. A competent person must also thoroughly inspect it regularly. He should look for deterioration, faulty hook springs, and loose or damaged mountings. Frayed edges, broken fibers, pulled stitches, or chemical damage might also be a problem. The competent person should check D-rings and D-ring metal wear pads for distortion, cracks, breaks, and sharp edges. On body belts, the repeated buckling and unbuckling can take its toll. The result, loose, distorted, or broken grommets. And belts should never have additional punched holes. When checking lanyards, the worker should begin at one end and work his way to the other end. He should slowly rotate steel and rope lanyards so he can see all sides while looking for worn or broken strands. When inspecting a web lanyard, bending the webbing over a pipe will help him check out each side. The snap hook should also be inspected for hook and eye distortion, cracks, corrosion, or pitted surfaces. The keeper or latch must fit into the tip of the hook without binding. The keeper spring should exert enough force to firmly close the keeper. And once the keeper is closed, the locking system should prevent it from opening. And the manufacturer's instructions on proper cleaning and storage must always be followed. If a worker's total body and tool weight is more than 310 pounds, then his personal fall arrest system may have to be modified. And one place to start, the manufacturer. The final component of the personal fall arrest system is the anchor point. Some possible anchor points are steel structures, beams, or columns. As a general rule, the anchorage point should be directly above the worker and easy to reach. This is to make sure that if he falls, he doesn't swing like a pendulum and hit anything. The anchor point must be able to support 5,000 pounds per worker. Or in unique situations, a professional engineer can design the system to withstand at least 2 times the possible impact load. Anchor points in non-engineered situations must be identified by a competent person who has been trained in fall protection systems and appropriate anchor points. All anchor points have to be regularly checked for weaknesses, deformity, cracks, and other signs that the points could fail. A convenient, flexible anchoring device is the horizontal lifeline system. The line must be able to support 5,000 pounds per worker or 2 times the possible impact load. The system should be designed by a professional engineer or a qualified person who can specify anchor points that won't fail if a worker falls. If you don't have a professional engineer to design a horizontal lifeline system, you can buy a system that will meet all the requirements when installed according to the manufacturer's directions. And like the anchor points, the horizontal lifeline system must be regularly inspected. The new subpart N doesn't cover scaffolds, ladders, or steel erection, but they're among the more common areas where construction workers fall. In fact, over 60% of fatal falls in construction are from these three areas. Scaffold requirements are covered in subpart L, ladders in subpart X, and steel erection in subpart R. More workers die in falls from scaffolds than any other surface in the industry. The first choice for protection of workers on scaffolds are guardrails. If they can't be used, then provide the workers with personal fall arrest equipment. But they should never tie off to the scaffold itself. Instead, they should attach the lanyard to a drop line, a rope grab, or an overhead anchor point. Employees have to be trained in the use, placement, and care of scaffolds. And a competent person must supervise the erection, movement, changes, and disassembly of scaffolds. When building scaffolds, erect them on firm ground. Make sure all braces, frames, base plates, and outriggers are secured. And install an access ladder, steps, or an equivalent safe access. Don't allow scaffolds to be overloaded. And have workers keep the working surface and access ladder free of debris, paint buildup, ice, and other slippery conditions. When planking, make sure properly inspected and approved scaffold-grade planks are used to cover the entire working surface. And finally, the scaffold has to be regularly inspected. Another common hazard in the construction industry is the improper use of ladders. There are different kinds of ladders for different jobs. The two most widely used are the portable extension and step ladders. Workers should always carefully inspect their ladders for missing, damaged, or loose parts. If the ladder is bent or damaged, it shouldn't be used. The ladder feet have to be on firm, level ground and not on slippery, uneven surfaces. And the work area around the ladder should be kept clear. When climbing, the worker has to face the ladder and center his body on the rungs. While working, he should keep his body centered on the ladder. He shouldn't overreach, lean to one side, or stand on one foot. This could cause him to lose his balance or the ladder to tip. So he must always maintain a three-point contact with the ladder. One of the most versatile and useful ladders is the extension ladder. But it must be set up and used correctly. The base of the extension ladder should be 1 foot out for every 4 feet of the ladder's working height. Before climbing to the working surface, the ladder has to be secured and extend 3 feet above the surface. This will allow workers to safely get to and from the working surface. Another popular ladder is the step ladder. When opening the step ladder, the spreaders have to be locked. Workers must climb up the working side of the step ladder. The highest safe standing level is the second step from the top. No one should stand above it. And a closed step ladder must never be used as a straight ladder. It will slip out from under the workers. We also need to look at the hazards that come along with the erection of steel. Connecting steel is among the high-risk steel erection activities. If placing members, tightening bolts, or installing purlins, employees must be trained to install and use fall protection systems. There are several conventional fall protection systems that you can use, such as safety nets, horizontal lifelines, and retractable lanyards. Workers might also choose to work from scissor lifts or man baskets. Since each construction project can be unique, the safety procedures and equipment must be pre-planned. There may be situations and circumstances when you believe conventional fall protection systems are more hazardous, impractical, or infeasible to use. But OSHA believes conventional fall protection systems can be used in just about every situation, so it's up to you to prove and document that the conventional systems won't work. In these cases, you can use specialized systems such as the warning line, controlled access zone, safety monitor, and fall protection plan. Each of the systems has been designed for a specific work situation, so be sure to look at the standard for the details of each plan or system. A warning line is a barrier erected on a roof that warns workers that they're near an unprotected side or edge. It also designates the area where roofing work may be done without using nets, guardrails, or personal fall arrest systems. Warning line systems can only be used for roofing work on roofs with a 412 pitch or less. On roofs steeper than this, you must use guardrails, nets, or personal fall protection systems. Controlled access zones are designated areas where work can be done without conventional fall protection. Leading edge, precast, and overhand bricklaying work can be done in these zones. If you use a controlled access zone, make sure the control lines restrict access to the zone and let workers know that only authorized personnel are allowed in the area. A safety monitor system can be used on low-slope roofs, outside of warning lines, or in a fall protection plan. It requires you to designate a competent person as the safety monitor. The monitor must warn employees of potential fall exposures and immediately do something to eliminate those hazards. He's required to be on the same surface and to be able to see the other workers, and they have to be able to hear him. The number of monitors depends on things such as the type of work being done and how close the workers are to the monitors. If the safety monitor system is all you're using, it has to be part of a fall protection plan. A fall protection plan is the last resort for fall protection, including the specialized systems. It can be used for leading edge, precast, and residential construction work only. The plan must be prepared by a qualified person. It has to identify the areas where conventional fall protection systems, like guardrails, nets, and personal fall arrest equipment, will not work and why they won't work. The plan must be site-specific, supervised by a competent person, include safety monitoring at a minimum, and include accident incident investigation procedures. A copy of the written plan and all its changes must be kept at the job site at all times. We've talked about the fall hazards that exist on construction sites, the conventional fall protection systems, and the more specialized systems. Now, we need to look at what we have to do to tie it all together. First, you need to identify the fall hazards. And once the hazards are identified, you have two options. You can engineer the hazard out, which means getting rid of it before the job even begins. Or you can guard against it by installing guardrails around open-sided floors, covers over holes, or safety nets underneath bridge construction. You can also use personal fall arrest equipment. But regardless of which system you use, you're required to develop a written program explaining how you will deal with each hazard. The program must list what equipment or system will be used and who will handle the supervising and training of workers. It also needs to include written proof that every worker has been trained in fall protection specifically for that job site. A rescue plan must also be part of the program. You have to make sure that rescue personnel, ladders, or other rescue equipment are available and that the rescue procedures have been practiced. If you use personal fall arrest equipment, it needs to be selected by a trained and experienced person. You're also required to train workers in identifying the fall hazards and on using the equipment. They must be trained by a competent person who is qualified in the following areas: identifying fall hazards, the right way to erect, maintain, disassemble, and inspect fall protection systems, the proper use of all conventional and specialized fall protection systems, the limitations of those systems, proper storage and handling of safety equipment, what the employees are responsible for, and Subpart M.
In summary, it's very important for a contractor to remember these very basic points. Number one, manage this problem. Develop a formalized safety program that deals with falls from elevation. Number two, make falls from elevations a part of your new employee orientation. Number three, be sure you reinforce your fall protection program or fall management program through the use of your toolbox talks and safety meetings. And number 4, enforce this program consistently and fairly on the job site.
If you have any questions or you need more information, simply look in your OSHA 1926 standard. It's all in there. It takes dedication and a team effort to see any construction project from start to finish. Protecting construction workers from falling requires that same dedication and effort.